Hello friends, welcome back to our channel. Today we'll see what is impulse and momentum and we'll solve one problem related to the impulse and momentum. So this is the important part of kinetics of the body and one numerical will be definitely asked on this topic. So this is very important topic from exam point of view and it is slightly related to your static part, so you can easily understand this type of numerical. So we'll start with what is momentum. So momentum, in simple words, we called it as product of mass into velocity. It describes the motion of an object and its tendency to keep moving. It depends on both the object mass and its velocity. So mass and velocity both are constant. If you want to increase the momentum, you can increase its mass or you can increase its velocity. So the unit of mass is kg and the unit of velocity is meter per second. So it becomes kg into meter per second. We'll take an example of car crash. So object 1, a small car of low mass is traveling at a high speed. It's collide with a large truck which is at rest. So despite the difference in the mass, the car can cause significant damage to the truck if they collide. This is because the car has a higher momentum due to its velocity. We know that momentum is equal to mass into velocity. Either you can increase the mass or you can increase the velocity. The product will have the higher value. So a small car of low mass, if it is traveling at a very high speed, it can cause a considerable damage to the large truck because of its momentum. So you can remember the formula of the momentum by last two letters of this spelling. So u is nothing but the velocity and m is the mass. So easily you can remember the formula for the momentum is equal to last two letters of the spelling, velocity into mass or mass into velocity. So this is one small trick for you to remember the formula for the momentum. Now we'll see one problem based on the impulse and momentum. The magnitude and direction of the velocities of the two identical spheres having frictionless surface are shown in the figure below. Assuming the coefficient of restitution as 0.90, so just mark this one. Also mark two identical spheres. So they are identical in terms of mass, same mass. Determine the magnitude and the direction of the velocities of each sphere after the impact. Also find the loss in the kinetic energy. So this question was asked in the December 2019 for 6 marks. So velocities are given with some angles. We'll analyze this question step by step. The first step is to resolving the given velocities. Mass A is present on the left side and mass B is present on the right side. So this is the first velocity of magnitude 9 meter per second and its angle with the horizontal is 30 degree. Make sure that all the angles are with respect to x-axis. So same method will use here that we have seen in the static part. So you can watch those previous videos to resolve the given force. Same way will resolve the given velocity. For that, on the free end, draw the coordinate system. So this is the x-axis and this is the y-axis. So you will come to know that this velocity lie in the first quadrant. Similarly, draw one horizontal at the free end of the second velocity and draw the y-axis. Now we'll come to know that the second velocity lie in the second quadrant. So in the previous videos we have seen this table. So if the force is outward and it's lie in the respective coordinate, so we'll get this kind of plus or minus sign. Okay, resolve the given velocity in x and y component, then only your answer is right. If you consider all the velocities are positive, most of the students make this mistake in this simple problem. So we'll not make this mistake. So for that, in the first quadrant both the velocities are positive. In the second quadrant the x velocity is negative and y velocity is positive. In the third quadrant, the x velocity is negative, y velocity is also negative. In the fourth quadrant, the x component is positive and y component of the velocity is negative. So we'll use it here. So for first velocity, that is 9 meter per second with an angle 30 degree. And we'll use a simple formula, fx is equal to f cos theta and fy is equal to f sin theta. Instead of that, we'll write vx is equal to v cos theta and vy is equal to v sin theta. So first one, the x component of this velocity a will be vax is equal to v cos 30. 9 cos 30, as it lie in the first quadrant, both the values are positive, and vay is equal to v sin 30. that is 9 sin 30. The answer is 4.5. Both the values are positive. Now for 12 meter per second, it lie in the second quadrant. So VBX will be minus 12 cos 60. Why minus? Because the x component is negative in the second quadrant. Then VBY is equal to 12 sin 60, and the y component is positive, that's why positive value is shown over here. So in this way you have to simply calculate the values of VAX, VAY, VBX and VBY with proper sign. After that, remember the line of impact. This is called as a line of impact. The impact is horizontal, so the line of impact is horizontal, so only x direction velocities get changed after the impact. Y direction velocities remains unchanged. Okay, remember this line. If the impact is horizontal, then the velocities in the y direction remains unchanged, and if the impact is vertical, line of impact is vertical, then velocities in the x direction remains unchanged. So just mark the y direction velocities, freeze them. So we're not going to change these y direction velocities, we'll only deal with VAX and VBX. So then we'll go to the step number 2. We'll apply conservation of momentum in the x direction because y direction remains unchanged. So apply only in the x direction. So momentum before impact is equal to momentum after impact. This is a simple line for the conservation of momentum principle. So momentum before impact for the given figure can be written as, so mass will remain constant after impact. There is no change in the mass, only change in the velocity. So for this body, ma into vax, velocity in x direction before impact, plus mass of b into velocity of b in x direction before impact, it should be equal to mass of a into velocity of a in x direction after impact plus mass of b into velocity of b in x direction after impact. So this is how we can write the momentum equation. This dash represent after impact velocities. Two identical spheres, mass of A and mass of B is equal to m. We'll consider it is equal to m for simplicity. So I'll put the values there. The ma get replaced by mass. Replace the velocity, Vx is equal to 7.794. mb is equal to m into minus 6. Don't forget to write minus 6. Most of the students make this mistake. They will not consider sign here, and that result into wrong answer. So it is equal to mass of A is equal to m, Vx dash, the value is unknown, plus mass of B is equal to m into Vbx dash. The value of Vx dash and Vbx dash is unknown here. So simplify this, take m common here. So 7.794 minus 6 is equal to, take m common here, Vx dash plus Vbx dash. So this m will get cancelled here, and 7.794 minus 6 is equal to 1.794 is equal to Vax dash plus Vbx dash. So this becomes your equation 1. So we'll use conservation of momentum to find out our first equation. I hope you understand up to this. Then the step number 3 is implementation of coefficient of restitution. So coefficient of restitution is equal to Vbx dash minus Vx dash divided by Vax minus Vbx. This is the formula which gives you the value of restitution. The value of E is already given in the numerical. If impact is perfectly elastic, then the value of E is equal to 1. If the impact is perfectly plastic, then the value of E is equal to 0. That you should know if it is not given in the question. Sometimes they only mention the impact is perfectly elastic. So for that you should consider the value of E is equal to 1. If they mention impact is perfectly plastic, then you should take the value of E is equal to 0. Now they have given the value of E is equal to 0.9. So 0.9 is equal to, put the value Vbx dash minus Vx dash unknown values divided by 7.794 minus of minus 6. So minus value should come here. Simplifying this, the addition of this minus minus becomes plus, so 13.794. Now multiply 0.9 into 13.794 is equal to Vbx dash minus Vx dash. So value is 12.4146, and we have just brought this term to the first place and this term to the second side to have the similarity in the equation 1 and 2. So this is your equation number 2. So by using conservation of momentum, we get equation 1, and by using coefficient of restitution, we get second equation. Okay, it is very difficult to make any mistake in this calculation because it is very simple, but you have to be careful while putting the values of the velocities in terms of plus and minus. Now we have got equation 1 and equation 2. This is equation 1 and this is equation 2. You should write all the terms at the similar places. First Vx, then here it should be first Vx, Vbx is second, so here Vbx should be second. Now solve equation 1 and 2. So Vx dash we get minus 5.31 meter per second and Vbx dash is equal to 7.10 meter per second. Object A is traveling in this direction and object B is traveling in this direction, right? But now after the impact they have changed the direction. This is traveling in the negative direction and this is traveling in the positive direction. So these are the directions after impact. Now we'll find out the respective velocities. So Vx dash is equal to minus 5.31 meter per second. Its y component will be similar to the initial or before impact y component Vay, that is 4.5 meter per second. Now we can find out the resultant velocity by using the formula square root of Vx dash square plus Vay dash square. Put the values there, so we'll get the value of Va dash is equal to 6.96 meter per second. The angle of the velocity can be calculated by the formula tan inverse of Vay dash divided by Vx dash. By putting the values there, we'll get the value of theta is equal to 40.28 degree. You can consider it as a positive or the negative, no issue. Then the next one, for the second mass Vb, x dash is equal to 7.10 meter per second and Vby dash will be equal to Vby, which was already freeze in the first step, and its value is 10.392 meter per second. Find out the resultant there. Resultant is equal to 12.59 meter per second and theta is equal to tan inverse of Vby dash divided by Vbx dash. The value is 55.66 degrees. So in this way we have calculated the absolute velocity of body A and body B after the impact. Now one more thing is asked. So in step 5 we will find out percentage loss of kinetic energy. The formula is kinetic energy before impact minus kinetic energy after impact divided by kinetic energy before impact into 100 for the percentage. So this kinetic energy before impact, it is an addition of both the masses. So the formula for the kinetic energy is half into mass into velocity square. So it is equal to half ma va square plus half ma mb vb square. So second body should be considered here. Then it is equal to half m into 9 square velocity of first body. Mass is they have the same masses, so mass is constant factor here. Half into m into 12 square. If the mass value is given, you can put the value here. Otherwise, you can keep m as it is. Value of this is 112.5 meter. The unit is joules. It is the energy, so it is measured in terms of joule. Kinetic energy after impact is equal to half ma va dash square plus half mb vb dash square. So that you have to consider it here. So Va dash and Vb dash are the velocities after impact. So it is equal to half into mass into 6.96 square plus half into m into 12.59 square. So the answer is 103.474 meter. The unit is joule. Okay, now I'll put in the above equation 112.5 into mass minus 103.47 into mass divided by 112.5 into mass. Now this m is common in the numerator and denominator. You can cancel it out and you can solve the equation. So loss of kinetic energy is equal to 8.023. As E is equal to 0.9, it is very near to E is equal to 1. So impact is more likely to be on elastic side. So there is less loss of kinetic energy is observed here. So by following these steps, you can easily solve this numerical and it is an easy chance to score 6 to 8 marks for your passing. So I request you to watch this video till the end, and if you have any doubt you can put it in the comment box. If you like this video, please share it and subscribe to our channel. Thank you very much.